Hey guys, I am having you enter into mid work on a Defender board set. What I have done is I have replaced all of the RAM sockets. I have replaced the two decoder sockets and the CPU socket. I have somebody had removed the 5101 RAM out of here, and they put a socket in this spot, and I don't know what was going on. Maybe this was something to do with the high score save kit, and you guys know what I think about high score save kits. I don't like them. Yeah, I don't. But this one was kind of hacked up right here. I had to do trace repair. I had to do a little bit of trace repair on this chip. You can see there, going off to the right. And underneath you'll see there's two traces I had to repair. And there was a pin pulled out of this socket for some reason. I don't know what was going on there. But the main problem with this set of boards was that it would boot up, but it would hang up in the setup screen. It would hang up, would not progress. And that is this chip. If this thing is not working, it will not run. So, and I've tested the RAM. The RAM was fine. It was the socket, and the way the socket was in the board was not good. So I had to fix that, and I have. I've got this guy all cleaned up. I got new caps in here, and this one had the Midway style bullet cap right here. It had the Midway style bullet cap, little black bullet cap that loved to blow up, that loved to short out, I should say. And this filters the unregulated 12 volts for the reset circuit. So it's probably got, I don't know, an unregulated 12 volts could be 20 volts, could be 24 volts, something like that. And I am amazed that that cap didn't blow up, to be honest, because they just short out. But I got 3 new caps here. I replaced the power header. Sockets are all done. This is a really nice, clean board. It's got a nice battery holder. It's not broken. It's not corroded at all. It's really nice. So there's no need for a high score save kit on this board set. Get a good working 5101 RAM, have some good lithium battery, AA's in here, and you'll be good to go. This board I have replaced the EEPROM sockets. I've replaced the cap and the power header, and I reflowed all of the headers on everything. Okay. And this sound PCB has some issues. Right now I've removed the sockets. I've removed the 2 sockets. I still have to replace them. This cap was in the board right here, and it was standing up like this, and I just didn't like that. So I'm going to put it in the board like this. Actually, I'll put this down, and then I'll run a ground wire to ground it. And this, I'll maybe put some glue down or something, glue this down on the board, so it'll be nice and flat. I'll probably replace the 5-volt regulator. And this amp has been replaced at some point in the past. That guy right there, that amp. You can see that is a newer amp. But if we flip this guy around and look at the work, it's pretty bad. You know, that looks like that trace is pulled up right here. right there. It looks like that trace is, I'm sorry about, I can't hold this still. But I think I'm going to remove the amp, clean that up, fix it better, and put it back in, make sure it's nice and clean, good connected, so that there's no problems in the future. Alright, somebody has recapped this, and these are fine, these caps are fine. They put new 1 microfarad caps in, but they forgot, there was another tantalum right here that they forgot. I pulled that out. I'll put a 1 microfarad cap in there, and I'll fix that 4700 microfarad cap. I'll replace the 5-volt regulator just for longevity's sake. We'll fix this proper. These have all been reflowed, it looks like. I'll take a good look at this. Make sure that, I mean, it should be fine. It needs to be cleaned up though, so I'll clean that up really good. Make sure the boards are nice and clean. See, here's my here's the ROM board where I replaced all of these sockets. You can see there's no messy residue left over at all. You always want to clean your work. And that's beautiful. And, yep, it's all like that. This board is also nice. And these are the RAM, where the RAM sockets were replaced. Yeah, the CPU. Here's the CPU. A little residue. Could use another brushing, maybe. Yeah. Well, yeah. And this that 22-pin socket for the RAM was kind of ugly. A lot of pads were pulled up. Yeah, there was a lot of pads pulled up off of there, so it was not ideal. Let me take oops. Let me take this and just kind of get some of that white dust stuff off of there. Yeah, it's still on there. Yeah. Anyway, yeah, there was a lot of pads pulled up off of that. But it's all good. It works. I mean, I went ahead and beeped it out, and it's fixed. Yeah, so anyway. So I'll have to do a little work on this guy, get this up and ready. The soundboard here, I'll have to finish that. And then this Defender set, I believe, has the nicest firmware set that I've ever seen for a Williams game. We'll take a look at it when I get it all put together. All nice red labels. I mean, it looks new. You know, the chips are great. So, all right. Well, that's a little update to catch you up to where we are. I didn't even try to turn this thing on when I got it. I straight out of the box and straight to the bench to start this maintenance work. And yeah, so we'll be firing it up together. Okay, and here is the board set all put together. We have 4164 RAM, which was already in the board when I got it. This had already been converted, and this customer has this adapter in his cabinet. You can either mod the board or you can use an adapter. Since his board is not modded, he could actually put 4116s back in the board and just eliminate the adapter, and it would work fine. So I'm not modifying the board at all. So I'm using my adapter, my 4164 adapter. This is what I'm talking about with these. I've never seen a memory set as nice as this. Even the decoder ROMs have nice red labels. And all the EPROMs. Very nice. And (472) 202, 472 202, 472 202. So this is a matching set. Now the soundboard is not matching. The soundboard is not a match. But this set is. And we are hooked up. I've got this thing all hooked up now, so we will go ahead. I've got the monitor already turned on. I have not turned this on. I've already checked the polarity of all my RAMs. And these are all matching RAMs, which is nice. Matching speed. They're all 150 nanosecond access. I've checked the polarity of all of these. We are all good to go. So we should be able to just fire this thing up and see what happens. So let's do it. Let's plug in. There we go. And we are on. There. That scared me for a second. Uh-oh. RAM failure. RAM failure. Okay. Did one of the legs not get put in the socket? It says RAM failure. I might have to look at the code. RAM failure. Oh. And there's RAM failure again. And I bet you it will boot and run. And if it does, it just tells me that there's something funky with this RAM. It's not a good matching set or something. Or just something with the RAM. They're cheap. Just not good quality or something. I don't know. Let's give this thing a minute. There it is, see? And it locked up. I wonder if that could be this. That could be a cable. That could totally be a cable issue. All right. I think I will double check all of my pins and stuff. Make sure everything's in socket. I'll be back. Alright, I've been poking around this Defender board set, and I came across something that was very kind of weird. This original ROM set here, which is so pretty with these labels, what I was finding was pin 21, which is, pin 21 is right here. And pin 21 is just pulled high. See, 21 connects here, 21 connects here. It's just pulled high through a 330 ohm resistor on each of these ROM banks. Here's the 330 ohm resistor, here, here, and here, and it just pulls that line high. Now what I found with these ROMs in the board, and I will show you what it looks like with these in the board, but for now, what I was finding on pin 21 was it was in a high impedance state, but it had a waveform on it, like a square wave on it, going both low and high, I think. Now, this is what I just wanted to see what pin 21 did with new ROMs in it. These are not programmed, so you see it's just, there's no program in these EPROMs. I just wanted to plug them in here and see what pin 21 did. And pin 21 with these ROMs in it is high where it should be. This is this bank, and then you got this bank here, pin 21. Okay, see how it's up at 5 volts. And then pin 21 here, 1, 2, 3, 4, pin 21. And you see it's up at 5 volts. Now what I'll do is I'll turn this off, I'll remove all of these, put them back, and then I'll plug the ROM set into the board and I'll show you what pin 21 looks like. Okay, now I've got the original ROM set back in the board and I've got it turned on, and it's, you know, giving me the old RAM failure. Okay. Now if we look at pin number 21 on this bank, see that? It's almost going completely low at times. See that? Now we'll go to this bank. Let me get on it. Okay, this one's not so bad, this bank. Alright, now we'll go to the next one. Can't see. There. Now this one's pretty bad. It's pretty, look at that. Yeah, I don't know. I'm not digging this. So I think what I'm going to do is I'm going to burn a set of ROMs for this and see what we get. See what happens. I'm going to replace all of the 2716s. I'm going to burn just 2816s for now because they're easy and quick. And plug those in here. I'm going to leave the 2532s in, but I'm going to program 2816s really fast and put into these spots and see what we get. And if that seems to be, then if that works that way, then we can do one at a time with these ROMs. Okay, and just to make sure that these 2532s aren't what's causing the flakiness, I pulled all of the other EPROMs out of the board. And, you know, curious enough, this thing will do it'll go right through the rug pattern with just 2 EPROMs in it. And then, but anyway, with all of the 2716s out of the board, I can probe pin 21, and you can see it is right where it should. Well, there's a little bit of nonsense going on. let me quickly reset it and then probe 21. See, this is just strange. Maybe it is the 2532. Let me do that again, but on this bank. See, now this one's fine. This one does not do any of that nonsense. And, well, I saw something. It's hard to have that. Let me try it again. 21. No, didn't. Well, it's. A little weird. A little weirdness going on here. There's something weird going on. And I don't know what. Anyway, we'll give it a shot. All right, I programmed all new ROMs, 2532s and 28C16s for there. And we're hooked back up. And we're going to fire it up and see if there's any difference. So here we go. So far, so good. ROM failure and RAM failure? Uh-oh. That ain't good. That ain't good at all. So we got issues. It does not like these ROMs. It does not like them one bit. All right, well, I want to probe pin 21 anyway and see if it looks different. I mean, that's bad news right there. So, yeah. All right. Okay, ROM number 12 had a bent leg. So it just came up, yeah, basic RAM failure like before. And it'll probably do the exact same thing. So it looks like even though there's something weird going on with that one chip, or with that, let me go ahead and reset it. Something weird going on with that. I mean, it's better now. Pin 21. It's better, but it's still, you know, I don't like how it still does it. I mean, it's weird. Maybe pin 21 needs a capacitor as well. This one's fine. And this bank is also fine. So it's just this one bank now. Yeah, looks fine. Okay. And this one, and then this one has a little bit of a drawdown for some reason. I just don't like that at all. I don't know why it's doing that. Pin 21. . That's pin 23, or pin 22. This is pin 19. 18. Yeah, now it's doing the exact same thing as it was before with the other ROM set. So even though that ROM set is weird looking like that with pin 21, that is not causing this problem. So, but it is nice to eliminate that as a possible cause to this. Before I start going in and analyzing, first thing I want to do is the muxed addresses. 4 addresses get muxed to access these RAMs. The microprocessor, this thing creates an address, this creates an address, and the video addressing creates an address. So there's 4 addresses that are muxed through these 4 153s to access this. Now I've already probed around and looked at the row and column select signals, and they all look perfect. And the shift load for these shift registers, which looks perfect. So all the control looks good. So I'm going to move on to the muxing to these, the address muxing to the RAMs, and then the data path back to the CPU, which is through the RAM latches. And then I have to look at the schematic. Then that RAM might be latched back through this 245. I have to look at all that. So, got to look at these paths. Make sure that addressing is getting properly to these RAM. And then make sure that data is getting properly pathed back to where it needs to go. So that is the plan. I've kind of eliminated this board. I wanted to eliminate program and that kind of stuff so that I can just focus my attention on this board. So that was what this was all about, was eliminating this. And that still doesn't eliminate this cable, but I don't see any flakiness. Now it's giving me a ROM failure again. But this is exactly what it's doing before with the other ROMs. Exactly. Now it'll reset. Yep. Exactly same thing. So it just does not like these ROMs apparently. So maybe I'll put the original ROMs back in it and just concentrate on this. That's what I'll do. Alright, I got the original ROMs back in it, but what I did do something. I basically, let me turn it off, show you what I did. Because I just didn't like that, how that noisy nonsense was like that. So what I did was I put 3 capacitors from pin 21 to ground. And if I plug this back in, we'll turn it on. Okay. And we're on. And I'll show you pin 21 is now much better. It's still, I still don't love it, but at least it doesn't have square waves going on it now. This is one bank. This is the next bank. Let me get on 24, 21. Right there. I mean, that looks great. And this one is still, I don't love it, but it is what it is. I mean, I don't know why these chips just are not the greatest, but at least it doesn't have square waves going on it now. So yeah, it's better than it was. I'm going to go ahead and hit reset, and I want to wait. I want to see this start the game and see what this looks like on pin 21. Right now it's sitting at the RAM failure screen. And soon it will start running. Trying to run anyway, and then it resets, remember. But we're not getting ROM failure messages, you know, so that's good. And this will be better in the long run for a little decoupling on that line. Now it's running. Yeah, it's not going low. I mean, it's not awesome, but it doesn't have square waves on it anymore. And it reset, so yeah. I don't know, these are just old tired ROMs, I think, and they let some decouple. They need decoupling, I guess. I don't know. So I put a little decoupling on. But now I'm going to move on to this board. I just wanted to point that out a little bit. A little addition to that circuit and make it a little more stable. So, okay. I'm going to start hooking up to this thing and doing some analyzing on addressing to and data from. You know, I said, and I tested, I beeped this all out. I beeped it all out, and I thought I beeped it all out. And I was like, you know what, I'm going to do it one more time. I don't know. Pin 15. Bear with me. Okay. Pin 15 and pin 15, that's supposed to have continuity. That's an address bit. 15 to 15. See, if you come over here and do 15 to 15. See that? 15 to 15. 15 to 15. Nothing. But if I go here, 15 to this, let's do this 15. Try to. This 15 to this 15. That's all good. It's just here to here's broke. Yeah. It's a bad trace. Sometimes it's just a trace. That's beginning to be an ongoing theme of my repairs. Sometimes it's just a trace. The only bad thing is this time it was my fault. It was my work. Well, we're not going to be cheesy and just do a wire on the back. I'm going to pull this apart. I'm going to remove these two sockets, and I'm going to find out exactly where this break is, and I'm going to fix it top side so it's nice and hidden. That's a little irritating, I tell you. But we're going to fix it proper to where you can't tell. So, all right. Well, I think I figured it out. I don't have to remove any sockets. There's not a broken trace. There were about 2 pads that came up. And normally that's not a big deal. It still solders perfectly fine. One of those pads happened to be pin 15 of that. It's not soldered. I did not solder that. So, yeah, I'm just going to solder it really quick and that'll fix it. Okay, I soldered that. Now let's see if we can do this. Pin 15 to 15. Fixed. All right, I'll put the RAM back in it. I removed all of the RAM, so I'm going to put them all back in it and see what we get. Okay, we are together. The original ROMs are in the board. RAMs are all in. Notches are all the right direction. Okay. These are 4164s. I have my 4164 adapter in the board. We're good. All right, let's fire it up. We're looking for unit OK. RAM failure. Oh, goodness gracious. Now what? I don't know. Why? What? I just reset it and see what it does. Oh, now it says unit OK. Huh. Very weird. Unit OK. Unit OK. Let's turn it off. Okay, we're off and back on. Unit OK. Okay, reset. Okay, well, I don't know why it did a RAM failure that one time. Yeah, I don't know, seems fine. Yeah, seems to be working fine. Huh. Anyway, yeah. Who knows? Anyway, well, this thing had these in it. And I don't think these are alkaline because I don't see anywhere where it says alkaline. I think these are rechargeable. Oh, no. These are alkaline. Alkaline. These cannot go in this board. For all of those who are watching this right now, do not put alkaline batteries in your games, because you'll forget about them and you won't open your game up for a year, maybe 2 years. These things will leak because they're constantly working. If you have your game off, I mean, they're always putting that voltage on this diode. They're always putting voltage on this diode. It's not moving any current because there's no potential difference on this diode. It's got 5 volts over here when it's running, and it's got 5 volts over here when it's running or not running. It doesn't matter. It's just your battery is always supplying current to this RAM over here when the game's turned off. Current doesn't flow from the batteries when the game's running, because the diode blocks it, because there's no current to flow through it, because there's no potential difference on either side. But when you turn that power off, the power on this side goes to 0, and then the voltage diode drop, you've got 4.5 volts here. Say your voltage drop across this is 0.6 of a volt. Let's just say 4 volts. So you've got 4 volts, you got 3.8, 3.9 volts from here over to your battery, or over to your RAM, which is, and current will run through that and run to here. So these things are always running. These batteries are always, as long as the game's turned off. And they're off most of the time when they're in a collection. And these batteries will kill it. Kill it. I will put some carbon zinc batteries in it. They are not alkaline. They do not leak. They will not destroy the board. So I do have those, and I'll put those in it. I don't even put these in my clocks around the house or anything. I don't use alkaline batteries for anything if I can help it. I don't put them in my tools, my meters and stuff, except for the 9 volt, because I haven't really found a lithium 9 volt, but I'm sure they make them. But everything, I use lithium batteries for everything. And if you want to put batteries in this thing and forget about it, get yourself some AA lithiums, Energizer lithium. Put those in there and you can just forget about it for years. And peace of mind, you know they won't leak and destroy the board. Little tip for you. Also, another tip is, when you replace sockets, if you don't solder them, it won't work. All right, I had a change of plan. Okay. First, let's look at the ROM schematic. Remember pin 21. Pin 21, they're all ganged together and they are tied high through a 330 ohm resistor. Okay? I got to thinking, why in the world do that? So many games you'll see pin 21 is tied high on a 2716, 2732 maybe, 2532 for sure. They're always just tied to pin 24. So with that in mind, the one that comes to mind right away is Pac-Man. If you look at a Pac-Man, you'll see that pins 21 is jumped right to pin 24. Straight to it. There's no resistor in between. So what I did is I removed the capacitors I put on the back. And I just put 0 ohm resistors in the pull-up spot. This is where the 330 ohm resistor was. Those 3 guys right there. So I put 0 ohm resistors in. And this is what it should look like. Here's pin 21 on all 3 lines. That's pin 21. Now it's pulled high. There's no doubt it's not floating halfway. Same thing with the next bank. That's not 21. That's pin 21. High. I mean, it's high at 5 volts. That's where it should be. And right here, this is the next bank. If you remember, you see where it's at right now? They were down here, almost at a high impedance state. You know, almost, floating, kind of almost just an unknown region. It could go low and the ROM not become enabled. That's just a bad design. So I would suggest to anybody that has a Defender, remove those 330 ohm resistors and just put short wires. Pull pin 21 high. It's much better. Makes more sense. So that I'm happy with now. And I have not seen it give any RAM errors since. But this will prevent that from giving false nonsense bullcrap. Because it's That's an enable. Pin 23 is an enable pin. Pin 21. Yeah, pin 21, not 23, pin 21. I don't know if I kept saying 23 or not, but it's pin 21. And it is a, it's an enable on a 2716. Pin 21. Pin 21 on a 2716 is not an enable. I don't know what it is. Let's look. 2716 pin 21 is 19, 20, 21 is the programming voltage. So that actually doesn't really matter, because that's like 21 or 25 volts to program this thing. So that could either be 0 or 5 volts. But still, I just didn't like that. So why not just hold it straight to 5 volts? It's not influencing anything now, you know. So now I get, yeah, okay, I get why they did it, because it's just a programming pin. You know. Yeah, so I don't know. Yeah. So anyway, I'd still do that, just right to 5 volts. So it's absolute. Yeah. I got to work on that soundboard and put batteries in this thing. I'm going to reset it. Okay. And have it come up with the old green test okay. Yeah. That was a fluke. I don't know what that was all about. Yeah, so, alright. Yep, let me get that soundboard out, clean it up a little bit. I got to replace a couple sockets on it. Clean up that amp. I'm going to replace the 5 volt regulator just for longevity's sake. And clean it up. Test it out, and we'll see what we got. Something I just thought of, which is pretty cool. I programmed 28C16s, which are electronically erasable and reprogrammable, right? 28C16. So if we look at 28C16, pin 21, pin 21 is write enable, okay? That's basically the program pin. So when that goes low, this thing will write, whatever's on data will write into this. It'll electronically erase and reprogram. I had programmed 28C16s for this board, and they got corrupted. And now I know exactly why they got corrupted. Is because of that pin. Pin 21 doing this and floating and going high impedance state and going low every now and again. It must have went low enough to where it reprogrammed my chips. You could use 28C16s in this as long as you did this. As long as you tie, you would have to. You would have to at that point. You'd have to remove those and put just short wires in there to tie pin 1 to 5 volts so it never would reprogram those 28C16s. But yeah, because I know I put the 28C16s back in after I figured this out. I put a few of them in. And it gave me a ROM error, so I know it rewrote my chips. So yeah, pretty cool. Just something to consider if you are working on a Defender and you're replacing your ROMs with 28C16s that are electronically erasable. You're going to have to, you would have to, at that point, you'd have to do this. You'd have to put those little shorts in so that it would tie that program pin, that write enable pin would have to be tied high. So I think you could use those now in this with no problem. But before, it just wouldn't work because they'd rewrite themselves. Yeah, pretty cool. Just wanted to point that out in case someone's ever tried to use those in here and have it not work. That would be why. Yeah, if I can get in close enough on this, you'll see that that is actually a broken trace. Oops. Come on, focus. This is as close as I can get. Yeah, you can see that's not connected. So this would have had no sound, I would think. I'm going to replace the power input header, as well as the two sockets and the regulator. I've got the little heat sink off of it. I'll replace that, replace these two sockets, fix this guy up, replace this cap, lay this cap down nice, and this thing should be good to go, I would hope. Alright, I've got the soundboard done. Okay, I got this guy laid down, and it's got hot glue grabbing the side of it and kind of going down there. There's hot glue underneath it too. It's laying on hot glue. That'll keep it from rattling. I just soldered it, I grounded it right there through that hole and just grounded it to that plane. Okay. I ended up replacing the amp. I just replaced it because I just don't know the history of it. And I just replaced it. So, and I got a little solder ball on there down there, but that's no big deal. It's fine. There's no pad on the other side, so it soldered. A lot of the solder just went straight right through it. Instead of pooling up on the pad underneath, there's no pad. So I replaced this. Sockets are replaced. This one. Replaced this cap. Replaced this power input header. And I have everything cleaned up. Yeah, here's that where there's no pad on this side. All the solder went right through and kind of balled up on the leg, which is no big deal. I got this guy just kind of folded over onto the trace and soldered right onto the trace. And I cleaned up all of this flux that was on these headers. Here's my new header. Shiny. Tested the fuses, they're good. So we're ready to go. We're ready to hook everything up. So we shall do that. See if our sounds work. Okay, we got the whole kit and well, we don't have the whole kit and caboodle hooked up. We need to hook this little guy up. Okay, now we got the whole kit and caboodle hooked up, and I want to be able to coin the thing up and do that kind of good stuff. So, and we'll just ground this here. Okay, this will be my tester. All right, let's fire it up. So far so good. Oh, RAM failure. Come on. This time it'll probably pass. I think it's these, yeah, I think it's just these RAM. You know what I want to do is I want to put different RAM in it. And reset again. Well, that's good. Sound's working. And now our game will come up. There you go. All right, let's coin up. And I think starts right here. hyperspace, reverse, up, up, down. Boy, it's hard to do. Hard to do this like this. But I have my suspicions about these RAMs. I think I'm going to go ahead and replace them and put something else in there and see what happens. Anyway, it's working. It's working fine. And I'm going to put some batteries in it. Be right back. Okay, I went ahead and I swapped all of these guys with all of these guys. Okay, and we'll fire it up. Yeah. Let's turn it off. And fire it back up. And I noticed something right away. I'm going to turn it back off. When these were in the board, as soon as you'd fire it up, you'd see a green screen over there. Okay? Now watch, I'll do it again. There's no green screen. See that? You know what's going on, don't you? I did not put batteries in yet. Okay. Yeah. Here's what's going on. -15. Okay, and if we read these upside down, this will say 4164-20. What does that mean, and is it significant? It is very significant. These will work. But these are 150 nanosecond access time RAMs. These are 200 nanosecond access time RAMs. It does matter. This game, I have found in my experience, when you have 15s in it, you have 150s in it, you will get random errors. You'll get, if it's a Joust or a Robotron type of game, if you have 15s mixed with 20s especially, but if you have all 15s, you will get random 131 RAM errors. That was the random 131 RAM error on this board with these RAMs in it. Because then it started and worked fine. So I'll go ahead, turn it off, and we'll start it back up. Yeah. You got to have the 20s. I believe, and let's start. I believe this will also work very well with 250 nanosecond. But when you go faster than that with these, it does not work good. So keep that in mind, that Defender Williams boards like 200 nanosecond, 250 nanosecond access RAMs for proper running. It will work with these. Sometimes if you have these mixed with these, it won't work at all. But like you've seen here, you know, I mean, it'll start with a RAM error, but then it takes off and it works. That's the random 131 error, Defender style. But this is working. The sound's working good. The every control was working good, so it is going good. So I'll include these RAMs because these ones, they will work in a pinch, but you're going to get the random RAM errors. So, yeah. But that's going to do it for this one. I'm going to call it good. We've tested it out. It works good. It's looking great. Sounds good. It's a nice board set, isn't it? Look at these ROMs. The labels. You got the red labels over here. Nice RAM here. Let me go grab batteries, and I'll be right back. And then we'll do a go over of what we did. All right. I got batteries in, you see. Those are carbon zinc. And if I zoom into this guy, and maybe get that out of the way, maybe. Nah, I don't know. Let's just try to turn it, maybe. Yeah, I'm going to check the voltage at pin 22 on the RAM. So, and here we go. And 4.5 volts. How about that? Heck yeah. So that must be a low forward voltage drop diode. A special diode. Germanium maybe? I don't know. Anyway. Anywho. So that's how that works. That applies voltage to the RAM when power's not applied. When power's applied, the voltage comes up right here. The 5 volts from the power supply comes up right here and meets this. So you have 4.5 here, and then you've got 5 over here. So current will not flow from the batteries anymore because it's being handled by the power supply. But when the power supply is shut off, this will drop, and as it drops, the battery takes over, and power, current is always flowing to that RAM. That's how that works. All right, so yeah, let's go ahead and fire this thing up again. And this time, after we it'll go to the white screen, that screen. And now we will just reset. And when we did that, this thing wrote the parameters or whatever for setup, for startup into this RAM. And I have checked it. I checked that RAM and I know it's good. So that should always hold the settings. So from now on, when you start this up, it should never go to that white setup screen again, unless the batteries die. So if we turn it off, now this time when we turn it on, it'll go through the rug pattern, then it'll go right to the Defender attract screen, if it's working. So let's go ahead and turn it back on. Unit okay. Uh-oh. Uh-oh. What's going on there? Uh-oh. Uh-oh. Okay. Huh. I did not expect that at all. Okay. Okay, now let's turn it off. And turn it back on. Yep, it's not working. The RAM I know is good. We know we got voltage over there. So I'm going to have to figure what is going on. So I will take a look at this thing and try to figure out what we got going on here. We're not done. And just to clarify this circuit right here, this diode, this barrier diode, is basically the control diode. It has 5 volts on it, and it conducts. It conducts from the 5 volt line, and it puts a voltage on the cathode end of this diode. This is where the battery voltage comes in on the cathode, or the anode of this 4148 diode. When the power is killed, the voltage across this diode dissipates, and when it does dissipate, this diode is allowed to conduct the battery voltage over to the RAM. So this one actually acts as a control diode for that circuit. Well, I have removed said diode from right there, and it is right here, and I tested it, and it tests just fine. 1N5817. I actually want to look that up. Be right back. Alright, from looking at the schematic, number one, I took this diode out of the board, 5817. I took that out of the board, and it tested just fine, so I put it back in the board. I just followed this over, and it comes down to this 4071 chip. It's a CMOS chip, and it's in that circuit, so I said it's the only thing else in the circuit, so let's just go ahead and replace it. So I did replace it, and we're going, turn it off, and it should boot right to Defender. And the battery is going to die, so it should come right to Defender. There it is. That was the issue, this guy right here. And guys, the battery is going to die on my camera any second, so I'm going to wrap this one up. We just proved you turn it off, turn it back on, it comes up to Defender. That means that this chip in that circuit was bad. So it's another Defender saved. Thanks for watching, and we'll see you guys on the next Classic Arcade Repair. See you next time.